What are you doing, Nick? अरे सम सर, लेक्चर 7 में आपने तो थ्योरी पढ़ा दिए, उसका एप्लीकेशन तो नहीं दिखाए। वही एप्लीकेशन के खोज में लगा हुआ हूँ। अच्छा, एक ही दिन में सब कुछ देख लेना है? इतना जल्दबाजी शास्त्र के लिए हानिकारक माना जाता है, ध्यान में रखिए। So, in today's lecture, lecture number 8, we are going to see the application of the theory what we have discussed in the last lecture, lecture number 7. Welcome YouTubers, कैसे आप सब लोग? Hope you are doing well. So, in today's lecture, lecture number 8, we are going to see the application of the theory what we have learned in lecture 7, and we will learn one more theory, okay, of three-dimensional geometry. So without wasting time, let's go to the blackboard. Okay, so the problem is find the vector and Cartesian equation of the line through the point 5 to minus 4 and which is parallel to the vector 3i cap plus 2j cap minus 8k cap. So equation, first we will find the vector equation. Vector equation of a straight line passing through a given point, a vector and parallel to a given vector, b vector is r vector equal to a vector plus lambda times b vector. So here a vector equal to, what is given? The point is 5, coordinate of the point is 5 to minus 4. 5 to minus 4. So 5i cap, 2j cap minus 4k cap, and which is parallel to the vector 3i cap, 2j cap minus 8k cap. So therefore b vector equal to, in that problem, b vector equal to 3i cap, 2j cap minus 8k cap. Therefore required equation of line is r vector equal to, where r vector is the position vector of any point, arbitrary point on the line L. We have discussed it in the previous lecture, okay. So 5i cap plus 2j cap minus 4k cap plus lambda times b vector. B vector means 3i cap plus 2j cap minus 8k cap. So this is the vector equation answer. The required equation of the line is this in vector form. In vector form. So what is the Cartesian form? Cartesian equation of the line is, so again we have learned from lecture 7 that when a given line passing through a given point and parallel to a given vector, this Cartesian equation is x minus x1 by a, y minus y1 by b, z minus z1 by c, where ABC are the direction ratios of the given line. Okay, so here direction ratios of B vector are 3, 2, minus 8. Therefore, x minus point is 5 to minus 4. And direction ratios of the B vector are 3, 2, minus 8. So this is the required. So name it as 1 is the required Cartesian equation of the given line. So if you directly come to this lecture 8, then my humble request to you, please go through the lecture 7 and also the previous lectures, then you can understand this application, that is the problem, very easily. Nothing is there. Okay. So we will go to the next page. Now today we will learn another new theorem of 3-dimensional geometry, class 12 NCERT part 2 book 11.3.2, equation of a line passing through two given points. Okay. So first we will draw the diagram. This is x-axis, this is y-axis, this is z-axis. This is origin. Say, this is the line whose equation we are going to find, say L. Let 2 points are given, say A and B on this line L. Okay. So let this is point A, say this is point B, whose position vector is also given with respect to the origin. Say this is B vector, this is A vector. Now we will take another arbitrary point on the line L. Okay, say P. Whose position vector is R vector, say. Okay. Now from diagram we will give the proof very shortly. Then we will go to the detailed proof in next slide. Okay. So if you need the detailed proof, then you can go to the next slide. Otherwise you can skip the detailed proof. You just understand the proof in short from the diagram only. Then, but at the last of the video, I will show you the application of this theory. So we will solve a problem at the last of the video. Okay. So from diagram, okay. So here from diagram, AB vector equal to P vector minus A vector. Actually OB vector minus OA vector. Triangular law of vector addition. Now if P be a point on the line L, then AP and AB vector must be collinear, right? Because from the previous lectures we have learned, if these are two lines, say this and this, okay, and say this is AB and this is AP. So if AB and AP are parallel and A be a common point, then it is obvious that A, P, B lie on the same line and A, P, B are collinear points. Okay, that is lie on the same line. So this concept we are going to use in that theory. So here to E be a point on line L if and only if AP vector and AB vector are collinear. Therefore, AP vector equal to some scalar multiple of AB vector. Next page. What is AP vector? AP vector means R vector minus A vector equal to lambda times of what is AB vector? B vector minus A vector. So we have got the vector equation of the line passing through two given points. Okay, so one is the required vector equation of a line passing through two given points. Okay. Now we are going to find the Cartesian equation. Here R vector equal to x I cap plus y j cap plus z k cap, right? A vector equal to x1 I cap y1 j cap plus z1 k cap, where x1 y1 z1 and x2 y2 z2 are coordinates of point A and B. Therefore, B vector equal to x2 I cap y2 j cap z2 k cap. So in the next slide, x minus x1 I cap y minus y1 j cap z minus z1 k cap. We are writing this from 1. In the equation 1, we are just put the values of A vector, B vector and R vector. Okay. So equal to lambda times x2 minus x1 I cap lambda times x2 minus x1 I cap y2 minus y1 j cap plus z2 minus z1 z2 minus z1 k cap. Where lambda is a non-zero real number. Okay, so simply we just put the values of R vector, A vector and B vector in equation 1 to get the Cartesian equation of the line passing through two given points. So next we just equate the like coefficients of the I, j and k. Okay, so from both sides we can write x minus x1 lambda times x2 minus x1, y minus y1 equal to lambda times y2 minus y1, and z minus z1 equal to lambda times z2 minus z1. This is nothing but this is the parametric equation of the line, because lambda is a parameter. Now eliminating the parameter lambda, we can get the Cartesian equation of the line passing through two given points. Okay, so by eliminating the parameter lambda, the Cartesian x2 minus, we get x minus x minus x1 by x2 minus x1, y minus y1 by y2 minus y1, z minus z1 by z2 minus z1. This is okay. So this say number 2. 2 is the Cartesian equation of the line. So we are done. Hooked. So this is a very nice theory. In the next page, in the next slide, we are going to see the application of this theory. आज एक ही दिन में सब कुछ दिखने को मिलेगा. Okay, next. Okay, find the vector and Cartesian equation for the line passing through the points this. So first we will find the Cartesian equation by the previous theorem. We get the Cartesian equation as here x1 y1 z1 equal to what? Minus 1 0 2. x2 y2 z2 equal to what? 3 4 6. So x minus x1 by x2 minus x1, y minus y1 by y2 minus y1, z minus z1 by z2 minus z1. We just put the values into that formula. Implies x minus x1 means minus 1, so plus 1 by x2 minus x1. x2 means 3 plus 1 4 equal to y minus y1 means 0, y1 means 0 by y2 minus y1, y2 minus 4 minus 0 means 4, z2 z minus z1, z1 means 2, and z2 minus z1 means 6 minus 2 means 4. So simply x plus 1 by 4, y by 4, z minus 2 by 4. Answer. This is the Cartesian answer. This is the Cartesian equation of the line. Answer. Now we have to find the vector equation of that line. Will I solve this today? No. This part, that is to find the vector equation if 2 points are given will be given as home assignment. So find the equation, that is the vector equation of the line passing through two given points, and put the answer in the comment section below. It will motivate me a lot. Okay, thank you for watching.